Hello, my dear students and the rest of the learners. Welcome to part 44 of a 95-part series of tutorials in object-oriented programming in C++. In this tutorial, we are going to continue with our topic by the title Inheritance, with our focus being on inheritance and the constructors, or what we call initialization. My name is Mema JM, or you can simply call me Emily Swap. A constructor is a special function of a class that is used to initialize objects. It is a special member function that takes the same name as the class name. In other words, when we talk about a constructor in object-oriented programming, we are referring to that function that has a name similar to the name of the class. For example, if you have a class name called X, then the constructor also is called X. So the syntax for a constructor is class name, then scope resolution operator, or in other words, two double colons followed by parameter list. For example, class name is X. Then we have two double or two colons. And then we have X followed by those brackets, special brackets, that indicates that X is a function. It is a function for the class called X. So the function name is X, and the class name is X. So constructors are invoked in the following order. Number one, version-based class constructors in the order of inheritance. That is followed by what we call the non-visual base class constructors in the order of inheritance. And thirdly, we have what we call the member objects constructors or constructors in the order of declaration. And lastly, we have the derived class constructor. It is important to know that the constructors are not inherited in the inheritance process, unlike other methods that are inherited. This fact puts the burden on the programmer to provide a compulsory special constructor in the derived class. The constructor is special because of the following reasons. Number one, it has to provide for parameters to cover inherited members as well as its own members. Secondly, it has the responsibility of allotting the incoming parameters to the respective constructor. A derived class object is composed of data members of the derived class as well as those of the base class, just as we have seen in the previous presentations in this series. Often, we need to initialize all of those data members while creating an object of the derived class. We must remember that when an object of the derived class is created, the compiler implicitly and inevitably embeds a call to the base class constructor and then the derived class constructor with respect to the object. Suppose performance is the base class and the score is its derivative, then the statement score first score semicolon is converted into score first score, that is memory allocated for the object. The memory allocated for the object score is called first score. Then we have base class constructor that can be called using a statement, as you can see, where we have first score dot performance. So simply, if you have a class a base class called the performance. If you have a base class called the performance, then the constructor for it, which is by the name performance, can be called using a statement, as you can see. That is the object for the class, followed by dot, the name of the function, that is performance. We can also call derived class constructor as follows. First score dot score. First score dot score. When a derived class object is created using constructors, it is created in the following order. Number one, virtual base classes are initialized in the order that they appear in the base list. Secondly, non-virtual base classes are initialized in the declaration order. Number three, or thirdly, class members are initialized in declaration order, regardless of their order in the initialization list. Number four, the body of the constructor is executed. The constructor's job is to set up an object so that it can be used. The constructor is therefore a function whose name is the same as the object with no return type, that is not even void. Constructors are used to create and initialize objects of their first class type. For example, if you have a class called results, whose definition is a constructor or a function which is called results, simply this results, as you can see, or this function has a name that is similar to the class, and therefore this is a constructor for class results. Now this is simply a prototype, and therefore the definition for this constructor can be done elsewhere. So we have a class called results, and we have a method called results. And therefore, because this method contains a name similar to the name of the class in which it assigns, then that is called a constructor. A class object with a constructor must be explicitly initialized or have a default constructor. Explicit initialization using a constructor is the only way to initialize non-static constant and reference class members. Constructors can initialize their members in two different ways. These are: a constructor can use the arguments passed to it to initialize member variables in the constructor definition. For example, you can have a method called complex, and this complex is receiving two parameters. One of the parameter is R, which is of type double, and the other parameter is I, which is being initialized to 0.0, or in other words, the content in it is being cleared. And then what does this function do? This function has the definition as follows: whatever value that is received as I is assigned to the member called IM, while whatever that is being received through parameter R is being assigned to a member called RE. And that's it. That's how that definition is done. Secondly, a constructor can have an initializer list within the definition, but prior to the constructor body. For example, you can have a member or a method. You can have a method called complex. As usual, this method or this function is receiving two parameters of type double. One is R and the other one is I, which is being initialized to 0.0. And then we proceed, and using or on the same statement, we assign R to re and I to IM, as you can see. And then we can define our function by writing the rest of the code. And that's how we can work on this method called complex. Both methods assign the argument values, the appropriate data members of the class. The following is therefore a sample program indicating inclusion of an initialization list as part of the constructor definition, not as part of the constructor declaration. So our program is by the name inheritance constructor initialization. We have hash include our stream using namespace standard. And then we have our class called B1, whose definition is composed of one member, data member, called B of type integer. And then we have a constructor by the name B1, which is public. And the definition for this constructor is simply a statement for outputting B1. In other words, a statement for outputting or indicating, a statement for indicating that the constructor called B1 has been called and it belongs to the class called B1. And that's what that section is meant to do. And then we can have our inline constructor as follows. So you can see we have our value I. We have our value I. Now, if you look carefully, I is being assigned to a data member, or our member called B. And we also have I, which is of type integer, being done what? If you can, or if you look carefully on this statement, we have I being assigned to B. And what is the scope? What is the scope for this? Remember that B is a data member, but B1 is a constructor, B1 is a constructor for which class? A constructor for the class called B1. And then the definition for this inline constructor is cout. Then we display that message there to simply indicate what has been or what is being invoked, what is being executed at that time. And that's the end of the definition for our class called B1. As you can see, we have a constructor called B1 with the definition, as you can see, and we also have inline constructor, as you can see, and B1, which is constructor, a similar name, the name of the class B1. We also have another class called B2. It has a member called B of type integer. Now, we also have a constructor for it called B2. And the definition for it is simply to display that the constructor which is being invoked or executed belongs to the class called B2. And therefore the constructor is simply B2. And then we have what we call non-inline constructor, B2. And it has a parameter called I of type integer. So next is B2 constructor definition, including its initialization list, is as follows. So this is B2 constructor definition, including its initialization list. As you can see, we are initializing even the member called B, value I. And then we display the cout B2. Then we have the scope resolution operator. We have the scope resolution operator, then B2. In other words, this statement is simply indicating that B2 is a constructor definition, or what is following is a constructor definition for B2 and its initialization. And then the cout simply indicates what is being invoked or executed at that point. We also have another class. Our class is called D. Now, D is a derived class. A derived class, which classes? Derived class 2, B1, and B2. So it is inheriting properties for class B1 and properties for class B2. The definition for it is that we have two data members called D1 and D2 of type integer, and we also have a public method. We have a public method, and this method is a constructor. And this constructor is called D, and D is receiving two parameters, one called I, the other one called J, and the scope for D is, or in other words, D is also, or can also be able to access the value or the member in B1, decrement that member I with 1, and also is able to access the other class called, or the other member, the other constructor called B2, the other constructor called B2. Now, if you look carefully in this program, my dear students and the rest of the learners, you can see that B2 here is a constructor of class B2. And also B1 is a constructor for class B1. And therefore, in this statement here, we can see that because class D is a derived class, it is able to access the methods, the constructor for the class B1 and the constructor for the class B2. It is able to access the constructor for B1 and also the constructor of B2. And also, it's able to access and assign or initialize the data member called D1 with I. And the definition for it is as you can see. Then we move on to the main program or main function. And here this is a declaration statement. We are declaring an instance for the derived class called D, and the instance for this class is object or obj, and at the same time, we are assigning into it one and 2. In other words, we are passing one values or 2 parameters, 1 and 2, to the caller through the object or the instance for the derived class D. So when we pass parameters 1 and 2, value 1 and 2, value 1 will be received by the first placeholder and 2 by the second placeholder in the list. And therefore, 1 will go as I and 2 will go as J. And next statement is return 0, telling the compiler to take back control the operating system, and the program will end. So the following is a demonstration on how to code, compile, and execute the program that we have looked at in C++ programming language. So as usual, my dear students and the rest of the learners, we are going to code this program in our word processor. Or in other words, you can copy this program in your exercise book or type it in a word processor. Then once you try run it, you can load C++ program. Then type this program into the editor, into the C++ editor, compile it, and execute it. So let's proceed by loading or starting C++ program in our computer, and then you proceed and we type this program into it. We compile it and execute it so that we can see how it will behave. So we are going to proceed to start our C++ program. So what we are going to do is I'm going to click there or press there, then I will start my program, Microsoft Visual C++ 2010 Express. From there, I'll click on New Project, and then with the tool console, what is the name of our program? The name of our program, as we have seen, is Inheritance Constructor Initialization. Inheritance Constructor Initialization. Inheritance Constructor Initialization. That's the name of our project. And then we are going to continue, have an empty project. And then we create a source file for our program. The name is Inheritance. You have seen the name is Inheritance Constructor Inheritance. Always you can remind yourself, it is Inheritance Constructor Initialization. Remember, you are always free to use any other name as long as you can be able to remember what it's all about. Always give your files meaningful names through which you can be able to tell what they are all about. Once you are on this window, you can proceed and type your program or your source code one statement at a time. However, if you have already coded this program in a word processor, you can just copy your program and paste it on this editor. And that's exactly what I'm going to do. I'm going to copy my program from a word processor and paste it on my IDE or my editor in C++. So what I'm going to do, I'm just going to open my program. This is my program that I've already typed in my word processor. So I'll just copy this program. I'll copy this program and then I just paste it on my C++ editor. If you have not typed your program in a word processor, you can still type it one statement at a time in your C++ IDE or editor section. Once you are through with the typing, you save your source code and then you compile your program. If it has any errors, you debug. If it has no errors, you proceed and execute. As you can see, our compilation has succeeded, meaning that our program has no bugs. So from there, we can just execute our program by clicking on debug, then start without debugging. And as you can see, my dear students and the rest of the learners, this is our output. Now, the purpose for this output is simply to help you see how the execution of a program that is implementing constructor initialization and inheritance can be executed. So from there, we press any key to continue, and of course, we save our work. So my dear students and the rest of the learners, that's how we implement constructor and inheritance. And with that, my dear students and the rest of the learners, we have come to the end of part 44 of this series. You can now continue to part 45 of 95, in which we are going to learn about inheritance and destructors. Congratulations, therefore, for learning part 44 of the series. Congratulations for learning part 44 of the series. I repeat, congratulations for learning part 44 of the 95 on inheritance and constructors initialization. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video on YouTube if it's not currently reading as subscribed. You can also join this channel as a special member to enjoy some additional rights and privileges by clicking on join and following the prompts that will be displayed. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 45 of this series, and God bless.